Hello and welcome back to the course of
Fundamental of Electronics and Electrical Engineering.
In this video lecture, I am going to discuss the terms related to the alternating quantity. Few terms we have already discussed in the previous video lecture. So let us see which are the terms topic that I am going to discuss in this video lecture. The first one is average value, then determination of average value using graphical method, then determination of average value using analytical method, then another term that is a RMS value, determination of RMS value using graphical method, and determination of RMS value using analytical method. So these are the two important terms that I am going to discuss in this video lecture. And finally, two factor, that is form factor and peak factor. So let us start with the average value. Average value or mean value of alternating quantity is expressed by DC current or voltage which transfer the same charge across any circuit as it is transferred by alternating current during the same time in the same circuit. The average value of alternating voltage or current is given by arithmetic mean of ordinates of alternating quantity at equal interval over the half cycle. For symmetrical wave, average value is calculated over the half cycle because average value of symmetrical waveform over full cycle is 0 because positive cycle value and negative cycle values are equal and opposite. So average value is a mean value. Now let us see how to calculate average value using graphical method. So here you can say one alternating voltage is there, that is a voltage, that is a plot of voltage versus time. Here half cycle is divided into the equal parts which are equally spaced and the duration of each part is equal. The half cycle duration is t and in one particular slot midpoint is taken which is known as the mid ordinate, which is nothing but the instantaneous value. So here you can see there are 10 instantaneous value in 10 different slots, that is V1, V2, V3, V4, V5 up to V10. And duration of each slot is t by 10 where t is the duration of half cycle. So how to calculate the average value from this waveform? So average value will be summation of V1, V2, V3 up to V10 divided by total number of instantaneous value. Here number of instantaneous value in half cycle is 10, so it is divided by 10. So V average is V1 plus V2 plus V3 up to plus V10 divided by 10. So this is how we can calculate the average value of a symmetrical waveform. If the waveform is asymmetrical, then we have to consider the full cycle. Symmetrical waveform means what? Positive and negative cycles are equal. So this is how we can plot average value from the given waveform. More the number of slots, more the number of instantaneous value, if we will take, then more accurate result we will get. Now next thing, determination of average value using analytical method. So again, considering the same voltage waveform, that is V is equal to Vm sin omega t alternating quantity where Vm is the maximum amplitude. It is spread over 0 to 2 pi. Now you can see some area under the curve. So basically average value is what? Area under the curve divided by base of the curve. Here area under the curve can be calculated using integration. So V average is equal to integration 0 to pi Vm sin omega t and with respect to d omega t because this waveform is plotted with respect to omega t. So V average is equal to integration 0 to pi Vm sin omega t d omega t divided by the duration of the base, that is pi minus 0, that is pi. Now taking Vm by pi outside, that because that is a constant, so V average is equal to Vm divided by pi integration 0 to pi sin omega t d omega t. Now integrating the sin omega t with respect to omega t, we are getting minus cos omega t. So V average is equal to Vm divided by pi in bracket minus cos omega t and limits are from 0 to pi. Now putting the value of the limit, we are getting V average is equal to minus Vm divided by pi in bracket cos pi minus cos 0. So V average is equal to minus Vm by pi in bracket -1 -1. So V average is 2 Vm by pi. If we calculate the value of 2 by pi, we will be getting 0.637. So V average is nothing but the 0.637 into Vm, where Vm is the maximum value of the given signal amplitude. So this is how we can calculate the average value using analytical method. Now point to be noted here is that we have to take half cycle if the waveform is symmetrical, if we have to take, and we have to take full cycle if the waveform is asymmetrical. Now, taking one example or to calculate the average value. So find the average value of the waveform shown below. Here one waveform is there, current waveform, which is denoted by I is equal to, mathematically can be represented by I is equal to Im sin omega t. Now here you can see between 0 to pi current value is there, between pi to 2 pi value of the current is 0. So this is a symmetrical waveform. Now to calculate the average value of this current, what we need to take? We need to take the entire duration. So I average will be equal to integration 0 to pi Im sin omega t d omega t divided by 2 pi. So I average is equal to Im divided by 2 pi integration 0 to pi sin omega t d omega t. So I average is equal to Im divided by 2 pi in bracket minus cos omega t. Putting the value of the limit, I average is equal to minus Im by 2 pi in bracket cos pi minus cos 0. So we are getting I average is equal to Im by pi. So here the duration is taken 0 to 2 pi. In the previous case it was taken between 0 to pi. Moving towards the next topic, that is RMS value. It is also known as the effective value. Now it is the full form of RMS value is root mean square value. Means for given waveform, first we need to take the square of that waveform, then mean, and then finally square root again. So what is the definition? So it is equal to the DC value which when flowing through the given circuit, that is a resistor, for given time produces the same heat as produced by alternating current when flowing through same circuit for the same time. It is denoted by IRMS and VRMS. Now let us see the explanation of RMS value. So here one basic setup is there. L is a filament lamp, S is a switch, X and Y are the two contacts. Initially, lamp is connected to the AC supply. So for some amount of time, AC supply is given and brightness is noted. Now DC supply is given, so switch is connected to the contact Y. Now DC will be given to the lamp and emitter will, A is nothing but the emitter that will note the current. Now value of the resistor is changed and at some time we will achieve the same brightness as achieved by the AC supply. At that point the current is noted in the emitter. That current is nothing but the RMS value. So basically RMS value is a DC value which produces the same amount of heat as produced by the AC current or AC voltage in the given circuit for the given time. Now let us see how to calculate RMS using graphical method. So here again taking the same voltage waveform, that is a voltage versus time waveform, alternating quantity is there. Now again half cycle is divided into the equal parts and midpoint of that equal part is taken, which is nothing but the mid ordinates value, instantaneous value. So again here we are having 10 instantaneous value from V1, V2 up to V10. Duration of each slot is T by 10, where T is the duration of half cycle, and here we have taken the 10 slots. So we are getting the 10 mid ordinates value. Now for RMS value, first we need to take the square of the value, then all the values are added, that is divided by the number of values, and then finally square root is taken. So RMS value of voltage is given by VRMS is equal to square root of V1 square plus V2 square plus V3 square up to plus V10 square divided by 10. So this is how we can calculate the RMS value from given waveform using graphical method. It is also known as a mid-ordinate method. Next one, calculation of RMS value using analytical method. So here one waveform is taken, that is a voltage versus time, and waveform is mathematically expressed by V is equal to Vm sin omega t. You can see some areas are taken, area under the curves you can see. Now, so Vrms we have already proved. So Vrms is equal to square root of area under the square curve divided by base of the curve. Or it can be also given as Vrms is equal to square root of mean of square of instantaneous value of voltage or current. So let us see how we can calculate the RMS value using analytical method. So Vrms is given by Vrms is equal to square root of integration 0 to 2 pi. Here full cycle is taken. Vm square sin square omega t d omega t divided by 2 pi. Because first signal is squared, so Vm square sin square omega t is taken, and the range is taken from 0 to 2 pi. Here average will not be 0 because we have already squared the signal. So range is from 0 to 2 pi, so base width is 2 pi. So Vrms is equal to square root of Vm square divided by 2 pi integration 0 to 2 pi. Now sin square omega t can be replaced by 1 minus cos 2 omega t divided by 2 into d omega t. So integrating with respect to d omega t, so what we are getting, Vrms is equal to square root of Vm square divided by 4 pi in bracket integration of 1 is omega t and integration of cos 2 omega t sin 2 omega t by 2. Here integration is done with respect to omega t. Limits are from 0 to 2 pi. So Vrms is equal to square root of Vm square divided by 4 pi, putting the value of limit 2 pi minus 0. So in bracket 2 pi minus 0. If we solve this equation, we can get Vrms is equal to square root of Vm squared by 2, and that value is nothing but the 0.707 into Vm. So Vrms is equal to 0.707 into Vm, where Vm is the maximum value of the given signal. Now taking one example, find the RMS value of waveform shown below. So here one waveform, same waveform we have taken. The voltage is varying between 0 to pi, and between pi to 2 pi the value of the given voltage is 0. So Vrms is equal to square root of integration 0 to pi. Here integration 0, here limits are from 0 to 2 pi, but between pi to 2 pi the value is 0. So here we have taken integration from 0 to pi. Then squaring the signal, Vm square sin square omega t d omega t, and base width of the given waveform, that is 2 pi. So dividing by 2 pi. So Vrms is equal to square root of Vm square divided by 2 pi integration from 0 to pi. Now take replacing sin square omega t by 1 minus cos 2 omega t by 2 into d omega t. Now Vrms is given by square root of Vm square by 4, integration of 1 is omega t and integration of cos 2 omega t is sin 2 omega t divided by 2. Limits are from 0 to pi. Now putting the value of the limit, Vrms is equal to square root of Vm square divided by 4 pi in bracket pi minus 0. And if we solve this equation, we will be getting Vrms is equal to square root of Vm square divided by 4, and that is nothing but the 0.5 Vm. So in this case we are getting 0.5 Vm. In the previous case we got the value 0.707 Vm, because here negative cycle is not present. So this is how we can calculate the RMS value of the given waveform. Now moving towards two important factor, that is the form factor and peak factor. So let us start with the form factor. The ratio of RMS value of the alternating quantity to the average value of the alternating quantity is known as form factor. So our form factor is given by RMS value divided by average value of the alternating quantity. Now we have already derived the RMS value and average value of the symmetrical waveform. So that is nothing but the 0.707 Vm divided by 0.637 Vm. Vm gets cancelled out. So form factor is 1.11. Form factor value which we are getting is for symmetrical waveform. If the waveform is not symmetrical, then form factor value will be different. The last one is a peak factor or amplitude factor or crest factor. The ratio of maximum value to the RMS value of the alternating quantity is known as peak factor or amplitude factor. So peak factor is given by maximum value of alternating quantity divided by RMS value of the alternating quantity. So we can write peak factor is equal to Vm divided by RMS value of the symmetrical alternating quantity is 0.707 Vm. So if we cancel out Vm, we are getting the value root 2. So peak factor is equal to 1.41. Again, this peak factor is for symmetrical waveform. This is all about today's lecture. In this video lecture, I have discussed average value and RMS value using graphical method and analytical method. Hope you have enjoyed this video. Thank you for watching.